Hello and good day to you. You're once again welcome to MES Construction. So we'll discuss all things engineering, architecture, and 3D modeling. Today we'll be learning in Protastructure how to design your waffle slab. In our last video tutorial, we were able to discuss on how to model your waffle slab, and in the lesson for today, we'll be designing our waffle slab and possibly also analyzing our waffle slabs. But before further ado, we encourage you to subscribe to our channel for more content like this, and don't forget to turn on your notification bell to be the first to see our latest tutorial videos on how to use Protastructure for your structural engineering design, analysis, and detailing. Thank you. Now let's get right into the video. So we have our waffle slab right here. From the labels of this waffle slab, we'll try to go through it again. We have this BW to be the width between your waffle cells, and in my last lecture it was actually 100. I changed it to 150, and the BW, if you use your measure tool to measure it, you realize that it's the distance between each waffle cell. You can see it right here, and your H is actually the depth of your waffle slab, or your waffle cell rather, the depth of your waffle cell, which cannot actually be seen in this 2D model or even in 3D model, but it can actually be described as the depth of your waffle cell that goes all the way down to the depth of your waffle beam. So you have your H slab to be the depth of your slab, or the height of your main slab from the waffle cell, and then the S block to be 400, which is actually the length and width of your waffle cell. And you can actually see that here if we use our measure tool. Once again, you can measure from here to here, and you see that we have 400. So now what we want to do right now is we want to design this waffle slab, and in order to go ahead to design our waffle slab, we need to first set our load combinations. And to set your load combinations, you need to go to your loading, and in loading we choose our load cases. Here I only have my load combinations to be the dead plus live load, and the dead plus live load plus the notional load on the x-axis. So I'm keeping it as simple as possible, so I'm not doing much here. So these are my load cases, and you can actually just go to your load generator if you want to add other load cases, but I'm not going to be adding any load case here. So I have my vertical load combinations right here, and then I have the horizontal load combinations right here. So what I'm going to do is I'm not going to be changing anything here, so I'm just going to press OK, and then I'm going to press OK. That actually popped up because I already designed and modeled this. Once I finish setting my load cases, I can go on ahead to decompose the loads from my beams onto the columns, the load from the slab to the beams and then to the columns, and I can do that by going to load decomposition by FE. And once I do that, you see that it brings up this panel just like we are designing normal slabs. So you can just click calculate slab loads directly, or you can just go in to check for your details here to see if everything is in order. Then you press OK. Preparing finite element model, processing slabs. So it automatically does that. Then at the end, we can apply to all beams in the model. So now we're going to close this. Then we apply to all beams in the model. We have this right here, and what we need to do now in order to design this is to go back to our modeling, and then we can actually just simply draw our slab strips. So in drawing your slab strips, as we described the other time, we will be using a span strip. However, this is an older version of Protastructure software, and in the older version, which is Protastructure 2021, so we can't use span strip for this. We'll be using a FE rip strip. That's the one we'll be using. But from any version after 2021, if you have 2022, 2023, 2024, there has been some updates on those versions, and you only have, I think you only have the span strip and the analytical strip available on those versions, and you have to use your span strip to design your rib or waffle slabs. But here we're going to be using our FE rib strip right here. So I'm going to be clicking it. So, but if you have newer versions, you need to use your span strip. Once we click on these rib strips, then we have to go here also to click on the direction that we want, and we are drawing in the X direction first. So we also need to go and observe our boundary conditions to input our boundary conditions here. And when you look at what we have here, we have going from beam to beam here for the X direction, and also from beam to beam in the Y direction. So we're going to be clicking from beam to beam here. You can see that this is starting from a beam, which is here, and also the strip is going to be ending on a beam, which is here. So this is actually from slab to slab. It's from cantilever to cantilever. So if it's from beam to, let's say it's from slab to beam, you have slab here, then you have beam here. So those are things we've already discussed in our previous lessons on how to design your slabs. Now let's get right into it. So we click from beam to beam, and then we draw a FE strip by clicking down on our control to ensure that we have a perfectly straight line. And one thing you need to also notice that when you are drawing your strip, you need to check if you are drawing on the x-axis, your delta y needs to be 0. And as you can see here, we have delta x is equal to 6,700, and then delta y is equal to 0, which means our strip is perfectly straight. And then we can click on that, and then we go to click on the y direction also. We have our boundary condition set here, and then we have our rib strip set also. Then we can go on to draw our FE strip. So you can see also we have delta x is equal to 0 and delta y is equal to 7,300. So we can click on that, and then this is how you draw your FE strip for your waffle slab. So since the load is transferred in both directions, both the x and y directions, unlike in the rib slab where loads are only transferred in a single direction, that's why we have both the x and y strip being drawn for this. So I can close this right now, and then what is left now is to try to analyze this. You may try to go and perform your load decomposition again just to be sure. Then close this, apply to all beams in the model. So now what's left for us to do now is to perform an analysis on this. And in order to perform your analysis on this, you need to perform a floor analysis, because a floor analysis is what helps your software to perform the analysis using the finite element method. So let's perform a floor analysis on this. So we can go to floor analysis right here. You want to ensure that your slab stiffness is lower than the thickness of your beams and your column and walls. Then you can go right here to also ensure that, and then we can press OK. Since everything is in order, then we press OK. Then you go right here to wait a little bit. The information for the analysis is right here, so you can just press OK on that. And here we're using short frame model, which is what we need for this project. So now I'm going to go and click on floor mesh and analysis. And I said FE model exists for this floor. Do you want to replace this? And that's because I've done an analysis on this before. So I'm going to press yes, and then allow it to do its thing. So you can see both our rib slab here and our waffle slab here. So we can generate model. And once you generate model, it kind of reloads what's here already. And then this looks good for me. We can go on now to close this, and then it tells us that your FE slab analysis is completed, and it takes us to post analysis processing and reports. And here I want to check what our slab analysis report looks like. So we are going to go to analysis post processing. And when you go there, you see that you have the parameters for your bending moments, your moment along the x and y axis and xy axis for the torsion. Then you have your required area of steel and all that here. You can also play the animation to see the nature of the deflections, but we don't have values on those deflections yet. And you can also see your load cases right here, your load combinations. So I'm just going to stop this, and I'm going to close this. Then it pops off with this and tells me if I want to transfer slab strip FE analysis results. I want to do that exactly and include in strip results. So I'm going to leave this as default as it's been clicked. Then consider torsion effects, wood and hammer in slab design. I'm going to click that as well. Then I'll press OK, and then I can close this and go on to my building analysis. And in my building analysis, I can try to set my materials. So let's go to columns. We want 16 for our columns. So in case you don't have this, because I've already set this, but it can come as random selections. So you can just unselect all, then unselect everything, just like I just did. Then you go and select the ones you want to select, instead of just trying to turn off the selections one after the other. Just press this first, it selects everything, then you press it again, it deselects everything, then you select the ones that you want to select. So I'm just going for Y16, and I press OK. Then for my concrete walls, I don't have any concrete walls. Longitudinal web bars, I don't have any. Horizontal web bar, none. So we have concrete beams. So I'm going to use 16 also for my beams. So you can do the same thing here, but I've already selected the diameter of the bar I want for my beams. If you could recall, we use this same project for our rib slab, so that's why you have everything properly selected here. Then for the slabs, I want Y12, and you can see I've already selected Y12. So, and for the rib, which is actually going to be the rib beams, I'm going to be selecting Y8 and Y10 just in case, for the section, in case maybe I run into problems with the section not being sufficient for my reinforcement. So I'll be choosing Y8 and Y10, but what I'm actually going to be needing is just Y10. So I can press OK there. Then for the links, let me choose Y8 and Y10 for my links. In case I have Y10, I need Y8 for my links, or probably Y6. So I'm going to be choosing these three: Y8, Y10, and Y6. So I'm going to press OK, then I press OK. We can go to model options. I'm just going to leave this as default. And we're also using user-defined supports. Mid-pair model, we are not really, confusing all this because we don't have a wall. So we're going to include slab in building model, and stories to be meshed, we're going to tick story 1, which is the only story that is in this project. Then use the compose slab and rib slabs loads in mesh stories. We're going to actually check that. We can go on to settings. So now we have everything set here. So now we can go on to analysis. And before you analyze, you need to do a building model check to know if your model is actually ready to go into analysis. So I'll start that, and then you can see that we have no errors here, number of errors 0, so we can easily analyze our design. So now let's carry out our building analysis. I'm going to just click that. Then I want column wall reinforcement to be designed, beam reinforcement also to be designed. I don't want bars to be selected. I just want them to be spotted. If they are failing, they should be spotted, and I'm going to redesign them manually by myself. So I click on building analysis and allow it to run. So we have our building analysis complete, and there are no pop-ups. Can go on ahead to check XGR load comparison reports. If there's any notifications, will have popped up, but there are no notifications. And you can see that our loads are properly decomposed, and the difference between building analysis and XGR load reports are not really far apart. So, and that's why we don't have any pop-up here. So, which is good. We can close this, and then we can also close this, and then we go to our analytical model to check what's there. And when you look at the dead load, you can click on displacement right here to know exactly what the value of displacement is. So we have our maximum displacement to be 1.35 millimeters, and then the minimum to be 0.0695 millimeters. So that's for the dead load, and the live load is usually smaller unless maybe you had some values of live loads to your design. We can go to G plus Q, that's dead plus live load, and you can see that the maximum is 2.4, which is okay. It's fair for this kind of project to be probably greater if we have a more complex project. So now I'm going to close this analytical model. So now we have designed this. What is next is to check our members, and this brings us to the end of our tutorial video for today on how to design your waffle slabs. Don't forget to subscribe to our channel for more contents like this, and remember to turn on your notification bell to be the first to see our latest tutorial videos on how to use the Protastructure software for structural design, analysis, and detailing. Thanks for watching, and bye for now.